A phone company's car just lost total power mid-corner on the most dangerous racetrack on Earth and still broke the record. Sit with that. 12 seconds. No power. On the Nürburgring Nordschleife, where one mistake at speed doesn't mean a fender bender, it means a wall. And the car didn't crash. It didn't even slow down enough to matter. It finished the lap, and when the clock stopped, it had beaten a Porsche. This actually happened, October 28, 2024. And the lap time isn't even the craziest part of this story. Because underneath that car is a material that, as far as anyone can tell, shouldn't exist. A metal that breaks a rule material scientists have lived by for over a century. And the company that built it didn't come from a defense contractor or a NASA lab or a 100-year-old steel giant. It came from Xiaomi, the same company that makes your $40 earbuds, your robot vacuum, your budget Android phone. 3 years ago, building a car was a punchline. Today, their car is structurally stiffer than a Lamborghini. Stiffer than a Lamborghini. And by the end of this video, you're going to understand exactly how and why the rest of the world should be paying very, very close attention. Before we go any further, if you care about who's actually winning the technology race between China and the West, hit subscribe right now, because what I'm about to walk you through sounds like science fiction. An AI that searched through 10 million possible metal formulas and found one no human would have tried. A factory press that presses down with almost the entire weight of the Eiffel Tower, and a battery that isn't just a battery anymore, it's the skeleton of the car. 3 breakthroughs, 1 company, and almost none of it has been picked apart by Western media the way it deserves to be. So let's fix that. Let's start with the what. The car at the center of all this is the Xiaomi SU7 Ultra, a 4-door electric sedan that looks on the surface like every other sleek EV coming out of China right now. Don't let that fool you. Under the skin, this car is closer to a piece of aerospace engineering wearing a license plate. Xiaomi spent over $1 billion in 3 years building it, not by hiring retired engineers from German automakers and copying their homework, but by starting from a question nobody else in the industry was even asking. What if you threw out every assumption about how a car is built and started completely from zero? Material, structure, manufacturing process, all designed together from scratch by a team that had never built a car before in their lives. That's the setup. Now, here's the how, and this is where it gets insane. For over 100 years, aluminum has been the gold standard of lightweight engineering. It replaced iron in aircraft. It helped cars shrink hundreds of pounds and hit fuel economy targets steel could never touch. Every major manufacturer on the planet, every single one, built their factories, their supply chains, and their engineering playbooks around it. Aluminum felt permanent, like a problem that had already been solved forever. Here's the problem nobody likes to talk about. To get real strength out of aluminum, you have to heat treat it. You take the cast or stamped part, load it into an industrial furnace, heat it to extreme temperatures, then cool it down at a precise controlled rate to lock its molecular structure into place. That process takes between 4 and 8 hours per part. Picture an oven the size of a shipping container, running around the clock every single day, just so that one structural piece of your car comes out strong enough to use. Now multiply that by hundreds of thousands of vehicles a year. That's not a manufacturing step anymore. That's an entire hidden factory, living inside your factory, eating energy and floor space and time. And on top of all that, heat causes warping, tiny unavoidable distortions in every part, which engineers have to compensate for with tolerances. Built-in slack across 300+ components in a typical aluminum car body. That slack adds up to a structure that is measurably less rigid than the one the designers actually drew on paper. The industry has known this for decades. They just had no alternative. So Xiaomi went looking for one, and they didn't send chemists into a lab to tinker for 10 years. They built an AI system working with China's National Key Materials Laboratory and used it to run something they call a material genome search. The AI tested over 10 million different alloy formulas. 10 million. If a human metallurgist tested one new formula every single day without taking a single day off, it would take them over 27,000 years to get through that list. The AI did it in a process that took a tiny fraction of that, and what it found wasn't a slightly better aluminum. It was something in a completely different category, an alloy. Xiaomi calls it Titan metal. that comes out of the mold already structurally finished. No furnace, no multi-hour bake, no warping to compensate for. It's reinforced with rare earth elements, built with around 40% recycled aluminum, and the molecular stability that normally takes a furnace to achieve just happens naturally as the part cools. Here's where it gets even more absurd. Xiaomi paired this with an AI-driven quality inspection system that checks every single cast part in 2 seconds. 2 seconds. That's roughly 10 times faster than a human inspector. And it's how they catch microscopic defects at a scale no manual process could ever keep up with. Now here's the kicker. A revolutionary metal is useless without a way to actually shape it. And Xiaomi didn't stop there either. You've probably heard of Tesla's gigacasting. Instead of welding dozens of small aluminum pieces together to form the underbody of a car, you inject molten aluminum into a massive mold under enormous pressure and cast the whole structure as one piece. Tesla's Model Y rear underbody went from around 70 separate parts down to just 2 castings. The industry called it the future. Xiaomi looked at that and said, not enough. Their system, they call it hypercasting, uses 2 presses with a combined clamping force of 9,100 tons. Picture the entire Eiffel Tower, all 10,000 tons of it. Now imagine that weight slamming down in a fraction of a second onto a mold the size of a car's floor pan. That press cluster alone covers an area of 840 square meters, roughly 2 basketball courts, and weighs over 1,000 tons itself. And because it's casting Titan metal instead of conventional aluminum, the part that comes out doesn't need to go anywhere near a furnace afterward. It's done. Let that sink in for a second, because here's what that actually replaces. 72 separate stamped and welded components and 840 individual welded joints. 840 points where a crack could start, where stress concentrates, where a structure can fail first, all eliminated, not reduced, removed, replaced by a single solid piece of metal, and the numbers stack up fast. That one integrated floor piece is around 17% lighter than the assembly it replaces. Production time on that part drops by 45%. Cabin noise drops by roughly 2 decibels, just from removing all those joints and seams. And Xiaomi claims the integrated floor is rated to last over 2 million kilometers, about 10 times the lifespan of a traditional welded structure. Read that again, 10 times. And then, here's the part that should make every EV engineer in Detroit and Stuttgart a little uncomfortable. Xiaomi did the same thing to the battery. In almost every electric car ever built, the battery is treated like cargo. It sits in a tray under the floor, bolted in, wired up, contributing absolutely nothing to the car's structure. Dead weight with a charge port. Xiaomi's cell-to-body architecture throws that assumption out completely. The battery pack, supplied by CATL, the world's largest EV battery maker, using their Qilin 2.0 cells, is bonded directly into the floor structure itself, sandwiched between the hypercast underbody above and a protective plate below. The battery isn't riding in the car anymore. The battery is the car, and this isn't some underpowered pack either. Qilin 2.0 is rated for a maximum discharge of 1,330 kilowatts. For context, that's roughly enough instantaneous power to run 1,000 homes at once. And on the Chinese testing standard, it's rated for up to 391 miles of range. Now here's the number that ties the entire structure together. Xiaomi says the resulting body has a torsional rigidity of over 51,000 Newton-meters per degree. That's a measurement of how much the car resists twisting when you corner hard or hit a bump at speed. A normal family sedan, built the conventional way, sits around 20,000. A Lamborghini Huracan, a carbon fiber supercar, is in the mid-30,000s. Xiaomi's phone company sedan is in a different league than both of them. A car built by the same people who make your robot vacuum is structurally stiffer than a Lamborghini. And the performance numbers that come out of all that? They're almost cartoonish. 1,548 horsepower, more than a Lucid Air Sapphire's 1,234, more than a Tesla Model S Plaid's 1,020, more than the Porsche Taycan Turbo GT's 1,092, 0 to 60 in under 2 seconds. That's enough acceleration to pin you back harder than gravity itself. 0 to 124 miles an hour in under 6 seconds. A top speed over 217 miles an hour. And on top of all that, Xiaomi claims a drag coefficient of just 0.195, making it, by that measurement, the most aerodynamic production car on Earth. Slipperier through the air than a Tesla Model S at 0.208, slipperier than its closest domestic Chinese rival, the Huawei Luxeed S7, at 0.203. Every one of those numbers on their own would be a headline. Together, they're a statement. Now, you're probably thinking, okay, but that record lap. Wasn't that car basically a gutted race shell with slick tires and a roll cage? Doesn't that feel like a bit of a stunt? And honestly, you're not wrong to ask. The car that ran 646.874 around the Nürburgring in October 2024 had a stripped interior, a roll cage, and was about as far from showroom as you can get. Porsche themselves pointed out, fairly, that it wasn't a clean apples-to-apples comparison with their own production records. Fine. Here's the part that crushes that objection anyway. 6 months later, Xiaomi brought back an actual, road-legal, showroom-spec SU7 Ultra. Normal interior, normal tires, a real driver, Vincent Radermecker, and sent it around that exact same track. It posted a 7 minutes 4.957 seconds, and that beat the Porsche Taycan Turbo GT's official production record of 7 minutes 7.55 seconds. Not the stripped prototype. The car you can actually walk into a showroom and buy. That's the one that now holds the title of fastest production EV ever to lap the Nordschleife. The skeptics' argument didn't just get answered, it got run over. So let's zoom out, because this stops being a car story very fast. The Nürburgring isn't just some racetrack, it's in Germany. It is, quite literally, the home turf of the entire German performance car industry. Porsche, BMW, Mercedes, all of them develop and brag about lap times on that exact strip of asphalt. It's where German engineering goes to prove it's the best in the world. And the company that just took one of their hardest-earned records wasn't Ferrari. It wasn't McLaren. It wasn't even Tesla. It was a smartphone brand from Beijing that started building cars 3 years ago. And it's not just German pride taking the hit. Across the Atlantic, Ford's own CEO admitted, publicly, that he'd been quietly driving a Xiaomi SU7 for 6 months and didn't want to give it back, calling the experience exactly the kind of wake-up call the American auto industry needed. Think about what that actually means. The head of one of the largest car companies in the United States is studying his Chinese competitor's product because he's worried about being left behind. And then there's Japan, a country that built its entire global manufacturing reputation over the last 70 years on precision, on incremental refinement, on doing the same process slightly better every single year for decades. What Xiaomi just did was use an AI to compress that kind of decades-long refinement process into a matter of months, in a material category Japanese manufacturers have spent generations mastering. This isn't a story about one car beating one other car. It's a story about the country that moves fast and builds versus the countries that refine and perfect. And right now, the fast and build side just posted a time that the refine and perfect side can't match. And here's the twist, because this story is bigger than even Xiaomi. China's electric vehicle ecosystem isn't one company having a lucky year. It's an entire web of manufacturers, battery makers, and materials labs all pulling in the same direction at the same time. Take BYD, China's largest EV maker, and their Yangwang U9. It's a purpose-built electric hypercar with a clever active suspension system that lets it do something almost no production car on Earth can do. It can physically jump off the ground while driving. And it does all of this for under 1.7 million yuan, under $240,000, a fraction of what a comparable Western hypercar costs. So now you've got two completely different Chinese manufacturers in the same year, both pushing past what Western and Japanese engineering teams considered the edge of what's physically reasonable, one with a structural battery and an AI-designed metal, the other with suspension that defies what suspension is supposed to do. And underneath both of them, quietly, is CATL, the battery supplier powering huge chunks of this entire ecosystem, from Xiaomi's Qilin cells to half the EVs on the road globally. This isn't a sprint between two companies. It's an entire supply chain moving in formation. And here's where it gets genuinely unsettling if you zoom out one more level. None of what Xiaomi built, the AI-designed alloy, the heat treatment-free casting, the structural battery, is exclusive to cars. Aircraft frames are some of the most complex aluminum structures ever engineered, full of thousands of joints, each one a potential fatigue point over decades of flying. A process that produces fewer, stronger, more dimensionally precise structural parts isn't just useful for a sedan. It's exactly the kind of capability that could compress how long it takes to build and certify an airframe. Same story for robotics. Humanoid robots and industrial machines need frames that are light, strong, and oddly shaped, exactly the geometry that casting struggles with today and that this kind of AI-designed, heat treatment-free process is built for. The technology that just embarrassed Porsche on a racetrack is, on paper, a technology that could touch aviation, robotics, and heavy industry. And right now, it lives inside one company, who built it not to sell it, but to keep it entirely for themselves. Now, I want to be straight with you, because this is the part most channels in this space conveniently skip. A lot of the headline numbers here, the 51,000 Newton-meter rigidity figure, the 10 million formula AI search, the exact composition of Titan metal, come primarily from Xiaomi themselves. The company hasn't published the alloy's full composition or its casting parameters, and no independent lab has verified these claims the way you'd expect in, say, a peer-reviewed materials journal. The headline 646 Nürburgring run was on a heavily modified, stripped-out prototype, and Porsche was right to flag that it wasn't a clean comparison, even though the follow-up production spec run still holds up on its own merits. And Xiaomi is absolutely not operating in a vacuum. Tesla pioneered the gigacasting approach in the first place. BYD and CATL are racing on structural battery integration too. And Western and Japanese manufacturers have the money, the engineers, and the manufacturing base to respond hard if, and this is the big if, they choose to prioritize it the way Xiaomi has. None of that erases what Xiaomi actually demonstrated on a real track in a car you can buy. But real and independently verified down to the atom are two different things, and you deserve to know exactly where that line sits. Here's what's going to stick with me long after this video though. A few years ago, the idea of a phone company building a car at all was something people laughed about at dinner parties. Today, that car is structurally stiffer than a Lamborghini. Its floor is one single piece of metal instead of 72, and its battery doubles as its skeleton. The future that everyone keeps promising, AI designing materials no human would think of, factories shrinking instead of growing, machines getting cheaper and stronger at the same time, that future isn't coming. It's sitting in a showroom in China right now, with a price tag on it, while half the world is still arguing about whether any of this is real. So here's my question for you. If a phone company can do this to the global car industry in 3 years, what industry do you think falls next? Put your guess in the comments. I genuinely want to know what you think. And if you want to be here when it happens, hit subscribe, because we're just getting started.